Okay, hello everybody, and welcome to the first session of the MLS Working Group. If you are here for another working group, please leave now. And if you're here for MLS, you're in the right place. So here's the note well. You've likely seen this before if you've been to any of these other meetings. Please read it, understand it, take it to heart. It's very important. So in terms of, before we start, we have a few requests. Minutes takers, we have a minute taker. Jabber scribe, we have a Jabber scribe, and a follow-up Jabber scribe. And let's pass the blue sheets out. As usual, we would like everyone to be able to understand who's saying what at the microphone. So when you come up to the microphone, state your name. This is not only for the people in the room, but it's for the remote participants. We have at least 6 on Meet Echo right now. So please keep it professional, and let's move on to the agenda. Here's the agenda. Let's open this up to agenda bashing. Does anybody have any questions about this or any suggested changes? No? Okay, so we'll do administrivia, charter review, architecture, and then several presentations about some of the documents that have already been presented and some of the ideas that have been discussed on the list. And at the end, we'll discuss a few other extra topics that are unscheduled. Let's start with the charter review. So since the BOF, MLS was incorporated, and here are some key excerpts from the charter. And I'm just going to go over these from a high level right now. The main important pieces are that this working group is here to develop a messaging security protocol for human-to-human communication with the above, and there's a list of properties in the charter itself, specific security and deployment properties. And the goal of this is for applications to share code so that there can be shared validation of the protocol. So everything that people use will underneath for this, anything that people use MLS for can use shared code, basically. And the goal is not to enable full interoperability or federation beyond the key establishment, authentication, and confidentiality. So we're really looking at the crypto here. We're not looking at making sure that different messaging protocols from a high level can interoperate. We're looking at standardizing the crypto. And another point is that while authentication is a key goal of the group, it's not the objective to develop new authentication technologies. Hopefully, what the result of this working group will be documents in which you could use X509 or other authentication techniques and plug them in, similar to how TLS does not define which specific authentication technologies are used. Okay, with that, we'll do the architecture review slides. Iman?
That's fine. Okay, hi everyone. I'm Imad Omara from Google. So basically, I will cover 2 presentations today, the architecture and message ordering. Both of them are basically overview of what we have today in the drafts, followed by a list of open questions to the group. Not necessary to get answers to all of them today, but just open the discussions. Hopefully we'll get some answer to most of them. So this is the same slides I used for the architecture in the BOF, because nothing has changed since then. Basically, I'll quickly go through the same slides again. So this is what a typical messaging system looks like: server side, client side, server, 2 services. Most of the time they operate under the same service, which is authentication, delivery. Client side members, each member has a bunch of devices. Each device in MLS is actually a separate client. Each has a long-term identity key. In this picture, there is a group of A, B, and C. E has 3 devices, B has 2, and C has 1. Okay. Authentication service basically stores mapping between long-term identity keys, between username IDs and long-term identity keys like email, phone numbers to identity keys. Delivery service ensures the reliable in-order delivery for message and attachment. It stores the init keys, which are signed by the identity keys, and optionally store group membership. So everything has an asterisk or star here is one of the open questions we'll discuss at the end. So store group membership is one of the open questions. Also, delivery service is responsible for evicting long-term passive user. This is to ensure PCS. Client, yes. This is our typical client operations, send, join group, etc. Since devices are represented as a separate client, so basically invite member, add device are the same operation, same for remove member or remove device are the same operations. So in this picture, A1 tries to create a group with PNC, so A1 basically requests init keys for A2, A3, B1, B2, and C1, verify the signature in these keys, create shared secret, and encrypt the message. Then B1, B2, and C1 will receive the message, recreate the same shared secret, and decrypt the message. Function requirements, scalability, obviously support large groups. The number we came up with 57 clients. Asynchronous, all operation can be done without having all devices to be online. Multiple devices should be supported natively because, again, device is just a separate client. Storing history is not requirements by the protocol, but again, the application can support this. Client state recovery, if the client lost state, should be able to restore the state without corrupting the entire group. Metadata collection, this is to protect user privacy, so the, both AS and DS should be collected the minimum data needed to deliver the message. Federation, as mentioned in what we discussed earlier, is that we don't expect interoperability at the application layer, but multiple implementation should be able to interoperate. Versioning, and I'm going to talk more about this at the end, but we should obviously support version initiation and have mitigation for downgrade attacks. Security requirements, of course, message secrecy and integrity authentications. Message should be decryptable by only existing members of the group, and only existing members can send this message. Another asterisk here, message padding to prevent traffic analysis, so this is optional. For secrecy and post-compromise security, to refresh our minds, forward secrecy means if the attacker has all traffic history and key K1 should not be able to decrypt any messages before K1, with key before K1. The other way around is PCS is if the attacker has K1 and some encrypted traffic, and then at time T prime, the key has updated to K2, should not be able to decrypt any traffic after K2. Group membership security, all members should have the same view of group members. This can be done by using Merkle trees, proof commitments. Client who joins the group should not be able to decrypt any message before joining. Clients removed from the group should not be able to decrypt message after leaving. Attachment security should have all the security semantics of any message except encryption key tends to be longer because of the attachment. Data origin authentications means no impersonations, so Alice can't impersonate Bob, send a message as Bob. This is usually done by having signature in every message. Typically, we can use the long-term identity for signature, but if we want to provide deniability, which will be optional, we'll have a separate signature key, and this signature key will be exchanged over the neighborhood channel. Security consideration. So what happens if delivery service compromised? So delivery service can always do DOS, which there is nothing to do about this, but it should not be able to do inject any message or reorder. And if it happens, the client should be able to detect this. If authentication service is compromised, however, it's more serious because it can allow impersonations. So it can return incorrect credentials, and we can use transparency logging or something like key transparency to defeat this. Client compromise, this is the worst case because attacker will be able to encrypt and decrypt messages, but it can be defeated after the compromised client has been updated their keys material. But it should not be able to do any DOS attacks against other peers in the group. I guess this is a list of open questions we have today. Not necessary to come up all answer today, but it's open for discussion. The first one, should the draft define the frequency of the updates or keep it completely open to the app? The other question came up during the POF, is some people concerned about exposing the user devices. And this is a privacy concern. Third question, is the server trusted to store group membership? And last one, should the draft have mitigation for traffic analysis or just forget about it?
Yeah, so So is this time for discussion? Great.
Yes.
So yeah, MT just reminded me one at a time. So I'll just start with the first one. Should the draft define the frequency of key update or leave it open to the application? I think the answer is yes. I think there's nothing we can do with the voluntary standard.
Yeah.
I'm elaborating here. So I think we should both provide guidance on the frequency of key update, but be realistic about how tightly we constrain the applications. So for instance, we might say, we really strongly recommend that you have you update your key at least once per day. But there are going to be things that are offline that are going to miss that budget. And so it's going to be up to the applications to make their best effort to meet.
So it will be just recommendation, not enforcing anything.
Yeah, I think that's right. And it's going to be about what the default normal case behavior of the app is, and they're going to violate their update budget sometimes.
Do we have a remote question from Ben?
Oh, can I respond to what he just said first?
Yes.
Shouldn't frequency be a function of how secure the key is? If you have weak keys, you'd want to refresh them more frequently.
We shouldn't use any weak keys. Yeah.
Okay, relative strength then. So.
I think they're orthogonal. So we have online question.
So regarding the question whether the server can be trusted to store the group membership, I think in a number of applications this wouldn't be an issue, but there are some applications where it would be an issue. So I think it would be a good idea to have it optionally work in a way that the server cannot infer who the group members are from persisted data.
Okay.
Okay, we're going to take a question from the queue here.
Sorry, Raphael Robert from Wire.
I'm going to take another question from online. Ben?
Everyone. So I'm Ben Dordouche. I'm working with Karthik in Paris at INRIA. So I wanted to discuss what Emad said and Richard about I think it's good to have a recommendation in the spec about the updating of the.
Hey Ben, can you be louder?
Yeah. Do you hear me now?
More, please.
Okay.
Scream.
Okay. Do you hear me now?
We can hear you, but you're quiet, so speak as loud as you possibly can.
Okay, so I think the recommendation from Richard seems a good idea to me. Like when updating the key, the group key one per day, the group secret once per day seems like a reasonable recommendation to me, especially because some security properties will actually depend on that secret, and maybe I'll come back to it a bit later in the message protection part. But typically, depending on if you want to get PCS for the message protection for the messages and not for the group secret, you will need to update more or less frequently the group secret. In that sense, I think updating once a day is reasonable.
Just to be clear, I'm not asking what should be the time. I'm just asking, should the draft propose a
recommendation? Yeah, my answer to that is yes. We should recommend something like one update per day.
Thank you very much. Stanislas Mushlev, CryptoPro. Stanislas Mushlev, CryptoPro. I totally agree with Richard that we should add some guidance about what to do with key update, and I think that there are a lot of techniques that you may know that in CipherG we have a document about keying that is closing to ISG period. That there can be some key hierarchy that the root key can be changed, for example, once a day, and the session keys can be changed much more frequently. But yes, I totally agree that we should add such issues in the draft, the document, maybe as a guidance or as best practices, but we should address this issue because we know some examples of messengers, for example, which have this problem with keys that are not being changed. So yes, this must be addressed, in my opinion. And second question I have here, do we address authentication techniques, authentication methods as part of the architecture or as completely independent, separate document and separate things to discuss?
So the way right now authentication is held out of band, but I guess Richard will talk more about authentication. You mean user authentication or message authentication?
Okay, thank you. Very good. Okay, thank you.
Eric Pascola. So I guess in sequence, yes, we should provide some guidance on key update. There are actually three reasons why you might want to do key update. One that was alluded to by the previous speaker, which I don't, not the previous speaker, not Alexa, Nastas, but which is weak keys. That's hopefully not really an issue in this case. If you rotate your keys, like once a day, you basically get something like like 4 or 5 extra bits of security. Like that doesn't really get you very much. But the reasons to do it are for key exhaustion in terms of AES keys, HGCM keys, and also for PFS and PCS. So we should provide some guidance on that. Though perhaps it should be a little like try to guide people on how to think about the problem as well as just spread numbers. I know DKG wants to talk about the protocol hiding user devices. Whatever he's about to say, I don't. We of course wrong. Exactly. More seriously, I think it would be good if it was able to, but I don't think that there seem to be a bunch of baggage. The problem is that while that would be a nice feature, it comes along with a lot of baggage, so we have to analyze what that baggage is and whether that baggage is something baggage we want to wear. My sense from current analysis is it is not, but it's not just like a yes/no kind of question. With regard to the server being trusted to store group membership, there are actually, again, 2 issues here, right? One is the server trusted to accurately report group membership, and the second is the server trusted to know group membership. The server should not be trusted to accurately report group membership for obvious reasons, and that should be pretty easy to cryptographically fix. In terms of the server being trusted to know group membership, it would sure be nice if we were able to build a system that didn't require that, but I suspect many systems in practice will end up having that information in any case. So again, we have to figure out what the baggage is there. Most systems I'm familiar with, as a practical matter, have to know group membership anyway, so it doesn't actually make that much difference. Finally, with regard to traffic analysis mitigation, I think we should not do anything here. I think there should be a section that says this is a huge source of information leakage. But every time I've seen anybody try to do this, it turns into an enormous rat hole. So I don't think we should actually do anything. If someone wants to produce a separate traffic analysis mitigation document, that would be fantastic. And I'm kind of hoping that PAIR-RG or whatever they're called will actually give us some help here. But I think we shouldn't that could show up a lot of working group time for not much value.
Okay. Let's close the line after Richard.
Hi, John Milliken. So on the topic of defining frequencies of key updates or recommending, I think we should include something on it, but we need to be careful that what we say will make sense for both 50,000 person groups and 3-person groups. So for example, if we were to specify we wanted to do it every day, for a 50,000 person group, you're going to end up with far more key update messages and cryptographic processing than you actually have useful messaging. But it very well may be that the security properties, when you get to that scale, are somewhat modified, or at least the expected security properties are modified so that a different key update schedule would make more sense. Whereas, if you've got a very small group.
I think for passive users, it's okay, they don't send any updates for a long time, but once they start sending messages, and if the recommendation is 1 day, and they have been sending any message for 2 days, with the first message, they should issue an update. But for passive users, I think there is no need to update.
I think we do need to be careful when considering that because of the PCS that we want. So in general, if any group member is compromised, or a global PCS guarantee would be that if any group member is compromised, there will at some point be the group's security will be healed. So if we want to aim for that, then we may have to consider passive group members. But in general, I agree with you, and that's what most applications are.
Thank you.
This is Daniel Kahn-Gilmore. I do believe that the draft needs to specify strong recommendations for key update. We have experience of not recommending key update schedules in other protocols, and people then don't implement them at all. Maybe they won't implement if we recommend, but if we recommend that we give them a chance. I recommend framing it as a minimum and maximum key update range because you want a maximum, well, I don't know, depending on talking about frequency or period, but if people re-update too fast, then we run into this problem that John describes, and if they update too slowly, then we don't get the PCS. But we should put in a concrete recommendation. And I agree with John that thinking about how we frame that with regard to number of groups is important. As far as hiding the user devices, I've mentioned this on list. The current arrangement where we are currently saying, well, multiple members and each member can have multiple devices and the devices are visible, that is a strict superset, I think, of what we minimally need to do. Minimally, we need one device per user, and the user could do something like MLS between their own devices to synchronize whatever key storage and state they need to synchronize. If the user doesn't do that, then they end up showing up as multiple devices. The reason I think we should avoid trying to get too deep into the weeds of the multi-device case, aside from it being more than we need to do to get something working, is because I believe that the multi-device case where every peer can see every other peer's devices has two problems. One problem is that I don't necessarily want you seeing my devices. And I don't think we have a good sense of how we can explain to the user a choice of, do you want to expose that you have multiple devices, or do you want to just pretend to have one, right? I think that's a bad question for user interface, and we don't want to give users the choice of switching in between there. And the second reason is because once your keys are being updated like that, and it appears that you have a new device, you're going to increase the number of notices that new devices show up, or you'll start removing those notices because they just get in the way. And so in the first case, you end up with security fatigue, which means you don't notice the actual big devices where a user gets rekeyed, which is the wiretap scenario. And in the second case, where it's all hidden, you can't notice it. So I think that if we go into the point of exposing multiple user devices, it leaks privacy and it increases the problem, the ease of inserting an additional key for a wiretap scenario, which I think we should be avoiding. We should be avoiding making this wiretap facilitation scenario. I will not comment on the third one, but on the fourth one, we need to include a mechanism for traffic padding. We do not need to specify exactly how to pad. But for the protocol messages in particular, all of the stuff that I've seen across the IETF, the application layer is what knows best how to pad. And so somebody who wants to write a draft should be able to do that at the layer of MLS. But we don't need to include the specific advice in the first round here. We just need to make sure that we have a mechanism for padding, that someone can write a document that describes the standard padding mechanism.
Thank you.
Hi, Lucia Ballard from Apple. Just a comment on the first point. I think having a recommendation here would be really useful. Having a strict requirement would potentially be a hurdle to adoption. Or if you go with the minimum maximum idea, making sure that minimum's pretty generous. Just because I'm thinking potential clients adopting this are going to vary hugely in their expected group size, in their sort of expected connectivity for group participants, and in the amount of already deployed infrastructure at scale that they have to deal with. So making sure that there's some flexibility there would be very helpful for removing barriers to adoption.
Yeah, thank you.
Thanks.
Bob Moskowitz, HT Consulting. Going through the list. I've seen so many scenarios, particularly in the IoT arena, where I think good guidance in different classes of scenarios would be very good, because one community may be very insular and not being able to think really out of their own box of what they may be doing. So they can see how, in this particular case, a different key update method will maybe used may open their eyes to a broader view of it. But in IoT arenas, with some multicast case, I've seen like you're not going to get key exhaustion for a few years, and the devices are not going to be updated for even maybe more years than that. So they don't even talk about key update in those arenas because of that. But But even so, those people should still think about some of the other cases. So good guidance, I think, is what's needed in the key update arena, and strong recommendations for certain scenarios. I would like to see how you're going to be able to hide the privacy of the user devices. This is really, really hard, and I'd be really interested to see how you're going to recommend that, because it might be interesting, or we may just be wasting a lot of effort to have some smoke and mirrors. Also, in many, again, it depends on the multicast cases whether you can not store the group membership. So that's really related to what you're doing with multicast. And so how does MLS have really anything to say to the group about what they're doing in terms of group membership store? So I think that's out of scope for MLS. The last one, I assume you're talking about traffic analysis of MLS, not traffic analysis of how those keys are used. Therefore, I strongly think that MLS itself needs to include traffic analysis mitigation. And I hope that that's what that point is talking about, not traffic analysis for other multicast protocols, secure protocols.
Hey, Richard, we're going to have a quick question from Karthik. Karthik, if you can keep it short, and then Richard, you'll have the last word.
Hi, guys. This is Karthik Bhargavan from India. Just a small question small comment about group membership, which is that I think it's an important question to ask at this early stage, what we really expect from to know about group membership. And I think a few other questioners have raised this point too. I mean, is it actually necessary for every member of the group to actively maintain a group membership list, to know immediately who the members of the groups are whenever the group changes? Or is it something that we want to be able to query on demand from some distributed set of participants, say? And this is just, I'm just throwing this out as maybe it's not clear cut that everybody should always be able to know who the other members of the group are.
Do you want to add something?
Okay, thanks, Karthik. This is Richard Barnes again. I spoke about the first one already. I'll just cover the other three briefly, which is largely plus one to what some other folks have said. With regards to Bob's question about hiding devices, I think the flavor of hiding we've discussed here is John Milliken came up with the phrase pre-trees, where you might have a leaf node in the MLS tree actually represent a whole subtree of devices that belong to a user. So from the perspective of the overall group, you would just see the user as one node in the cryptographic state, even though there might be that node might be a compound of other ones. And that's kind of what I think what DKG was referring to. Pick your three-letter acronym. DKG was referring to when it was talking about running the protocol among your own devices, which I think is exactly the right way to think about this. I don't think we really need to get into the details of how you might go about hiding things. We don't need to treat that as a first case use case here. Just as I think we can just note that one could do this if you wanted to protect device privacy. I'm largely on the same page as Ecker with regard to storing group membership. The only thing I wanted to note was something that I think John and Raphael raised, pointed out to me, was that we might not, we might use the server as a cache of some information, but not require it to store the whole membership of the group. So we might trust it to store a collection of public keys for nodes in a cryptographic state, but divorced from identity information about the participants. I think John's nodding. I think that's sort of what we're saying. So we might trust the server to cache some stuff that's kind of not identifying of participants, and so not sensitive. But I think the general requirement here is let's just think about how much we require the server to cache versus what would be useful for it to cache in terms of distributing information. Finally, traffic analysis mitigation. To Bob's point about what we're talking about mitigating, I think the intent here, I don't think anyone, at least that I've been chatting with off list, has been thinking about protecting the MLS key exchange messages. I think we weren't even thinking about encrypting those. So those are just like handshake messages that the system can see. I think the concern here is traffic analysis mitigation with regard to the messages that would be protected by a message protection scheme that Benjamin's going to talk about in a couple of presentations. And I think the answer is roughly what I forget prior person said, that we should have some padding mechanism in here, but leave it to the applications to decide how to use it.
So to summarize, we almost all agree that we have some guidance for the first question, like min and max style. Should protocol have user devices? I guess we might add option for this, but we can still continue discussion for this part. Is server trusted store ownership? I guess the conclusion is just maybe optional, but don't require per se. And the last one, we should include some mechanism, but leave it to the app to decide how to do it. Correct. Okay.
So question for you, Ahmed, is as editor of this document, do you feel like you have guidance to go off and get some text changes?
I think so.
Great.
Great, thank you. Let's have the next speaker come up.
Hold on. So before that happens, can I see a show of hands of who has read this draft? A fair amount. That's good. The previous draft, the architecture draft.
Yeah.
Because what we'd like to do is do a working group adoption hum. So if you've never done this, I'm going to let Nick do the actual hum. But the idea is that we have an individual draft now, and we're going to make it a working group draft so that we can take it. I think it was good that we have these open questions because it shows we've got work to do. So it's not fully baked. So that's perfectly okay. But we've got a good basis of a place to start. Is there anybody else who has a competing draft that they would like to throw into the ring? You cannot do that. All right. So here you go.
Okay, so the hum is going to be for adoption of the draft as a working group document. The draft specifically is Iman's architecture draft. So if you want this draft to be, if you agree that this draft should be adopted, please hum now. If you disagree that this draft should be adopted, please hum now. Pretty clear.
So for the minutes, we'll take it to the minutes.
The remote was also yes.
Thanks. All right, Iman, let's move over to the next one, handshake message ordering.
Perfect. So handshake message ordering. So this is basically specified in the protocol draft. I'm going to quickly explain the problem and the solution described in the draft, and again, open question at the end. So what are the handshake messages? They are any messages change the group states, like group init, user add, group add, remove, or update. Each handshake message is based on the current group state, and we choose the epoch field for this. Of course, conflicts can happen if two or more clients issue the same handshake messages on the same group state. Usually this can be solved using server-side enforcing or client-side enforcing. In both approaches, that might cause starvations. So a given client may not be able to send handshake message because it will always get rejected. The way I understand ART versus TreeChem, however, John is going to explain the difference more in the next presentation. TreeChem doesn't have this problem because it's able to merge concurrent updates without rejecting any of them. So the way server forced ordering is message will have authenticated sequential number, which is the epoch field, and the delivery service will just process them in order. And if it receives two or more messages on the same sequence number, it will just pick one of them and reject all the others. And the rejected client will retry again after updating their states. The way I understand client forced ordering, please, Rafael, correct me if I'm wrong, it's based on two steps, or at least this is how it's described today in the protocol draft. The client proposes the update first, and it sends the update if it gets 50+% by other clients. The question here, what if most of the clients are offline? Like, is it 50% from the online user, which is a security issue, or how it works? So these are the three open questions about this. The first one, should this section be moved to the architecture doc instead of the protocol, like covering this message ordering? The problem is this only specific for any protocol that has shared group state. If we're using something like sender keys, they will not have this issue. So the question, should we this be overall in the architecture doc or not? Again, back to the server delivery service trust. Is the delivery service trusted to enforce the ordering? What's the security consideration if it does? And regarding starvation, it is actually a real problem in busy groups, or in practice, it might never happen. Like it will eventually issue the update. And it's open for discussion again.
So yeah, I think it would be good for the architecture document to have a very clear statement on this. The question here is what assumptions the protocol document can rely on. If the protocol can basically assume that clients are presented with a linear sequence of handshake messages, that dramatically simplifies the client logic you're going to have to put into your stack. So I'm very much in favor of making a clear statement in the architecture that whatever the delivery service is that's providing delivery for this protocol, it ensures that all of clients receive handshake messages in the same order. And that frees us up in the protocol document from having to do anything about what happens when things arrive in different orders at different clients. This is a simultaneous add or simultaneous update question.
So you're okay with the server trusting?
Yeah, I am comfortable with trusting the server to enforce ordering, but as long as we can assure in the protocol that the only thing the server misordering things could result in is a denial of service condition. So we should make sure that the trust in the server is bounded, but as long as the server can't do anything besides deny service or fragment the group, I'm comfortable with that degree of trust in the server, because the server can cause those sorts of failures anyway. On the starvation question, I think that's a real potential problem, but I think it's something where, just tactically speaking, I would be comfortable pushing forward with a solution that had some risk of starvation, doing some prototyping, getting some experience in real-ish environments, and then if starvation looks to be a problem in some cases, looking for some methods we could use to try and address that as an addition to a baseline protocol that's linearly oriented.
Go ahead.
Yeah.
No, I was going to comment that the concern I have is with server trusted is the server might reject a specific update for a specific client, so which means risk the BCS for specific clients. But if we do bundle the update with the message itself, this means the message will not be accepted unless the update is accepted. We can mitigate against this, but this is just an idea.
This is DKG. So on the security considerations slide back on 14, it says modified, reordered, or replayed messages must be detected by the clients in the event of delivery service compromise. So I think that goes to what Richard was saying, that there needs to be a detection. I confess, I'm not sure that I know
Let me clarify here. So there is no reordering. This would be preventing from updates. So the client will reject updates. So basically it's a DOS attack. So the server will reject updates. This means...
I'm trying to address the questions about forcing the ordering, not about starvation.
Okay, so ahead.
Yeah, sorry, I wasn't clear about that. So I confess, I am not entirely sure that I understand what reordered means in a distributed messaging system. What does it mean to say that the server, if the server reorders the message, that's detectable by the clients, when we're talking about a messaging system where there is no canonical source of truth about when the message was originated?
Well, if two messages coming from the same client, for example, can send two before one.
So we're talking about just about...
Yeah, this is the way the ordering works, right? Either replay attacks, replaying the same message multiple times, or reorder messaging from the same client.
So just from the same client?
Yeah.
I would state it a little differently. I think the risk here is in handshake messages, so the key exchange protocol. I think we can tolerate arbitrary reordering in the message protection, as Benjamin will talk about in a second. But I think the risk here is that the key update messages are premised on a given state. And so if those are delivered in an order that doesn't correspond to a linear evolution of states, or if they're delivered in different orders to different clients, that can cause clients to end up in inconsistent states. Right. And so I think that's the type of reordering that's the concern here, is that there's not a consistent ordering in terms of, if all clients don't receive key exchange messages in the same order.
Right, so the
objective here is to have clients agree on a sequence of cryptographic states. And so if the server can reorder messages to to change, to cause clients not to agree on that. Like that's the type of reordering I'm concerned about anyway.
Anyway, it sounds to me like we're not entirely clear that we're all talking about the same thing. So it might
I think
behoove
you're
us to
talking about
write it
regular.
down.
Sorry, I think you're talking about regular message in the architecture presentation, and Richard talking about the handshake messages here, right?
I'm talking about the handshake messages.
You're talking about handshake
Yeah,
messages.
I mean, I think there's a separate set of questions about transcript consistency, which I'm not trying to cover right now.
So this time I will agree with DKG. I think it's clear that like the system can't enforce like strong ordering like guarantees between two simultaneous updates from different people. Like Eric Rescorla. Well, no, I mean like if you and I send updates like at the same time, like approximately the same time, there's like no way for the system to guarantee that the one that was like sent in like a normal relativity in like wall clock time, like 2 milliseconds before the other is the one that's delivered first. Like the server can obviously word them in any way it pleases. I mean, like unless you've invented some new synchronization mechanism I'm not aware of. So I mean, at best in that respect, what we can do is we can guarantee that the messages within a client are delivered in the right order, handshake or not handshake. Similarly, like the server can obviously suppress, the server can obviously suppress messages from any client it chooses. And so what I think, as I think we agree there has to be transcript consistency, otherwise the system doesn't work properly. And to what Imad was saying earlier is the what we should be targeting here is you can't selectively suppress handshake messages while delivering application layer messages. And in terms of being able to detect reordering and message deletion, then that's what that gives you, which is to say that if you have consistency within a client, and I receive messages 2, 3, and 5, and they're all messages, and then I'm missing message 4, then I know that's been deleted. And then you have to contend with why did the server not deliver that? Now, if you want to go beyond detection into suppression, one might wish to make handshake messages in some way indistinguishable from application layer messages, so that it was difficult for the server to selectively suppress those. But there's only so much you can do. I do think, by the way, that to Richard's point, that I think that it's totally reasonable at this point to say we're going to effectively trust the server to do this properly, and then attempt to detect when it fails to, rather than try to build a system which operates properly in the face of an arbitrary and malicious server. That would be too difficult.
Thank you.
Yes, Raphael Robert. So to the first question, I think it should be part of the architecture document, especially if the answer to the second one is yes, because the server is then very much part of the architecture. And so to answer the second one, we have to look at what the options are. So one thing is what you outlined, Imad, is that it's being decided on the client side. And for that, we would need some sort of mechanism where clients can actually decide on the order without relying on the server. And that is difficult because you pointed out that it has to be asynchronous. So finding some consensus asynchronously sounds a bit contradictory. I'm happy to be proven wrong there, but it sounds like a tough problem to solve, especially if you don't want to add a lot of overhead. And the other option would be if ordering is not really that necessary. So this comes down to art or TreeChem, which I think John will mention later. So for art, ordering is absolutely necessary. For TreeChem, you have a little bit of flexibility for some messages because some stuff can be merged, but it's still not fully flexible. So I think in practice, the best solution right now would be to trust the server for that. And regarding the starvation, this really comes down to the scope and the amount of messages you have at the end of the day. So if the scope is really only the handshake messages, personally, I don't think we could ever run into starvation frequently. Because if we have so many handshake messages that many participants and devices send them out at the same time constantly, then we have a general problem, I think.
That makes sense.
Jonathan Lennox, I was just I think the question with starvation is you want to make sure that clients can distinguish genuine starvation from, some malicious server or potentially even malicious other group members falsely making you think you're being starved and locking you out of the call. I mean, I guess it's kind of the same DDoS attack, just denial of service attack, just by dropping a malicious server. But I want to make sure that you can tell a malicious server from genuine starvation.
Bob Moskowitz, perhaps I'm showing my age, but where's the state machine? If we're talking about reordering, the rest being important, there must be a state machine here someplace, and the state machine should handle all cases. My professor, way back when, 40 years ago, whatever, would not let me do anything like this without including the state machine. So if we're concerned about it, we should be able to talk about that. And again, maybe I'm just showing my age on that. And so the state machine would then tell us whether we can trust the ordering and the rest of it. So that's what I say about that. Starvation, that's DOS attacks. So yes, it's a real problem and it will occur. So again, it's how do you recognize and understand that? And again, the state machine should show that. Again, showing my age, sorry.
Thank you.
John Milliken again. So I think my take on questions 2 and 3 is one of it would be lovely, and I don't know if it's possible. It would be lovely if we could get to a state where the server can do nothing to the security properties without actively blocking people's messages. So obviously, if one person can never send a message, then PCS with respect to that user is going to be compromised. But if we can get to a situation where, so long as everyone can intermittently get messages through, global PCS can advance, then that strikes me as the property that we should probably be aiming for with respect to them.
Okay.
Yeah, just to emphasize on this reordering semantic, the order that is important to preserve here is not the order of origination of messages, which, as Ecker accurately points out, is interfered with by relativity. The important thing to preserve is the order at which messages are received by the participants, and that you can easily enforce that with things like two-phase commit. So there's a variety of mechanisms we are well known we can use to preserve that property. So with regard to starvation, I think something that might be useful to do here is to have kind of a starvation consideration section here. Because another thing I might trust the server to do, Jonathan mentioned malicious other clients trying to emit a lot of update messages so that no one else can advance PCS. And that is something where you could have the server do some stuff to help. Like it could recognize especially active clients, or it could recognize that this client hasn't had a chance to update in a while, so let him in. And so it seems like you could put some considerations like that in the architecture, and in terms of recommendations for things servers should consider implementing. Finally, I wanted to end with a question. The thing that I'm actually surprised hasn't come up yet is federation, because this consistent ordering is super easy to implement in a single server system. You just have a lock, and you wait to get the lock before you transmit. But it's harder to implement in federated systems where you might need collaboration among domains to synchronize when messages can be transmitted. So I'd be interested to hear from folks who are interested in that use case. As we've said in the charter, it's not a primary use case here, but we don't want to have real hard barriers here. So I'm interested in whether people think this would be a real hard barrier in federation.
Yeah, Daniel Franco. Ecker is of course correct. That you can't totally order messages in an asynchronous setting. But that doesn't mean that we necessarily have to settle for just ordering messages from each individual participant. There are very, very nice middle grounds here, like vector clocks.
Okay. Hello, Michael Matoski from Dark Mirror, first time attendee, first time speaker. I may have misunderstood the problem, so apologies ahead. But with respect to messages and ordering, when we're talking about end-to-end, and I guess that's what we're trying to achieve here, server here is strictly to facilitate certain things. So when we talk about security and the server's roles in all of this is to harden the model, not necessarily to make it secure. Yes. And therefore, when we talk about the order of messages, I see two types of messages. Messages that are specific to a state, in which case, like the gentleman mentioned, a state machine or cryptographic binding to that state is important, and that solves the problems of server trying to mess around with the order. With messages that don't really affect the ordering, just need to get there, that's a different problem. So I think it's important to separate the space of the type of messages go through, because some messages need to tie to, are specific to a state, some are not. And those that are tied to a state need to be somehow bound to that state, either cryptographically or through other means. So you're sort of, this is to the point where the server is just facilitating transfer instead of ensuring some security properties.
All right, Leif Johansson. So I was thinking about your question about federated, the case, and I'm wondering whether, since this is human communication, whether it might be enough to be able to inform the user that there is sort of that the various endpoints don't agree on a particular message order, right? So if you can show that, right, and that might be enough in the federated case, right? I'm not entirely sure you have to force ordering in for every case, but as long as the user knows that there is contention in a particular case about, say, a pair of messages, right? Whoever you're chatting with believe that they are actually in a different order. You may have to work that out, but since this is human to human, maybe you can maybe that's enough.
Sorry, Michael Mutoxin, one more comment. With respect to starvation, I may be wrong, but there's not much you can do. I mean, depending on the capabilities of your attacker and the adversary, right? If they can control the network, they can potentially compromise the server because the server is sort of less trusted. I was just to mention that probably you want to include some mechanisms where a client understands that he was not able to participate in the ecosystem for a period of time, at which point he refuses to participate at all. To say that, you know what, I wasn't able to participate, therefore I have no trust in the system anymore, and I'm going to back out until some recovery mechanism is in place. So this is to say that you can control the world, but the client can say, you know what, I'm going to be defensive, I'm not going to participate if it doesn't play by the rules.
Brian Wise, Cisco. So traditional group security systems tend to trust the servers and have a lot less trust in the clients. And I sense from this effort that it's all the way, it's flipped around the other direction. We're trying to trust the clients and not the servers. And I think that's not clear at all in the architecture, and even not in, for example, the second question here. I'm sorry? Don't trust anybody. So I think that is even more important, that the architecture itself needs to just make that statement and make bounds around who is trusted to do what, and who really is trusted to generate keys, who really is trusted to decide when there's a key change. Those are. It's really hard when you don't trust anybody. So you've got to assign some amount of trust to somebody, and then in the architecture level.
Okay.
John Milliken again. Just in response to Michael's point about clients deciding that they have been locked out for long enough and they're going to stop responding. I think some of the offline discussions I've had with people about this, I've been discussing maybe if the protocol can automatically expire clients which have been silent for long enough.
Yeah.
So rather than the client deciding that it's going to kick itself out, everyone else decides that they're going to kick the client out for the purpose of advancing.
Yeah, the architecture document specifies this.
Sorry. Yeah. Cool.
Okay, so the way I understand the answers is yes for the first question. For the second question, the server is trusted to do the functional delivery or the functional ordering, but not the security semantics. So, and if there is any compromise from the server, it should be detected by the client. If the server did anything with this, the client should be able to detect it somehow. Do I understand correct? Starvation, when I mentioned starvation here, I meant innocent starvation, like functional starvation, not attacked by server or attacked by other peers, because both of them are addressed in the architecture document. Peers cannot DOS other peers, and with the idea we have with minimum and maximum key update, this should solve this problem. You can really actually issue updates all the time. Yeah, question.
Oh, yeah, I was just going to say, as author of the protocol document, which is not yet adopted, but maybe in the future, the takeaway I'm getting here is that the architecture document is going to document this requirement that the delivery service provide a consistent delivery order for handshake messages to clients, and I'm going to rely on that in the protocol document.
Yeah. By the way, should it be called handshake messages?
That's just that's the terminology we have in the document. Now we can change it later. And I think what I'd like to see for the third one is that we have some considerations around how to address starvation, and then we keep an eye on that problem as we move forward and see if we need mechanism to improve the situation.
Okay, the way I see starvation is if it's intended starvation by the server or other build, just a way of DOS, like should be covered in the same DOS section or not.
I think clearly we need to document that it's a condition that can arise.
Okay.
I think we should also document some things that the server can do to help if it arises due to malicious clients.
Sounds good. Any other question? Okay.
Okay, thanks, John. John, you're next.
Cool. So I'm just going to talk about sort of the big open question of what should lay at the heart of the protocol. We've got two proposals at the moment, ART and TreeChem, and this whole thing is an open question rather than the specified open questions at the end of Emmad's slides. Please pop up and ask questions at any point. First, to just kind of refresh us on what the various operations we have to support at. So we've got group state stored in somewhere. Both of the proposals at the moment are in key trees of various forms, and every participant caches some view of the tree. And then the operations that we have to have are being able to create a group, add users, users add themselves to the group, users update their own keys in the group, and being able to remove users from the group. So this is just the key exchange protocol. It's somewhat divorced from the messaging itself. So the first protocol, but to borrow my slides from the BOF, is called asynchronous ratcheting tree. Came up with this last year, and it's based on a Diffie-Hellman binary tree. So any leaf can be updated in logarithmic time by updating the leafs tree and then, the leafs key pair and just recursively recalculating the entire setup to the root. This can operate asynchronously. We have proofs in the paper linked of the confidentiality of the group keys in this setting, only for static groups. This paper does not fully prove ART as used within the MLS protocol doc, but it's partway there. And within MLS, we've actually defined some things that were left out of scope in the original paper. So we have additional constraints on the tree structure. As I said, we allow membership changes, and we talk a bit about race conditions, which we have the luxury of assuming do not exist in the paper. So the fundamental building block of this is Diffie-Hellman and a way to derive a Diffie-Hellman key from a Diffie-Hellman output. So if A and B perform a key exchange between them, they get the output AB, which they can then use to derive a key pair. And then AB and CD can then perform this, etc., recursively up the tree. And so, for example, you could do X25519 just of the hash of the Diffie-Hellman output. We found at the hackathon the other day that if you just use a raw SHA-256, there are a bunch of potential tricky potential conflicts that happen. But yeah, this is just an example. We do not recommend this in practice. To note terminology here, so with respect to C, we've got a bunch of terms. So we have obviously the root of the tree. We've got the direct path, which is in bold. So that's C and all of its ancestors. We have the copath, which is the sibling of all of C's ancestors. And then the frontier, which would be the siblings of all of the ancestors of a hypothetical new key to be added to the tree. So the direct path and the copath are all with respect to a given node. The frontier and root are with respect to the tree as a whole. And from a leaf and a copath, you can compute the entire path of that leaf. So the way we anticipate the group evolving is that this is just used as a mechanism for inputting into a more general group key ratchet. So the tree root is KDF'd into the existing group ratchet, etc., etc. So we don't just require the correct tree, but we require the correct order of trees as well. So the first operation, create group, there's very little to talk about this. A has a Diffie-Hellman key, and that's pretty much it. In the art paper, we defined this as starting with a pre-existing group. In MLS, we don't do that yet. We just assume it's the one-member group, so there's very little to talk about this. Here's a combination of later operations, such as the group-initiated add. So this is a situation in which a member of the group wants to add someone to the tree. At this point, they take an init key. These are also known as pre-keys in other protocols, which has been pre-published by the user that's going to be added. They generate a Diffie-Hellman key, which they then publish alongside the init key. And from this, the user can generate the rest of the tree. So they also have to publish the path. Sorry, no, in this diagram, the add key is sent to the other members of the group. And so everyone has either the add key or the init key's private key and can recalculate the rest of the tree based on the frontier of the group. The next option is the user-initiated add. So this is D adding themselves to the group. As the frontier has already been published, all D has to do is perform the Diffie-Hellmans with its own key. It's fairly straightforward. For PCS, this is when someone wants to rotate their key. PCS being post-compromise security, that is, future secrecy, as it's also known. So B simply updates its key, recalculates its path, and publishes all of the public keys up the path. And then everyone in the group should be able to calculate with respect to one of those public keys what the root is. And then removing is essentially an update where someone performs an update to someone else's key by replacing it with an eviction key. This has some intricacies that I've omitted from this slide, but we have a double join problem where you now have whoever's evicted the other member now knows some other node in the tree. So if they were to be removed, they would still have access to some state of the tree. In the protocol doc, we talk a bit about how we can address this. So as an alternative to this, Barnes, Ecker, and Karthik came up with this alternative approach, TreeCam. So this is a new primitive as opposed to the Diffie-Hellman key tree, which we were used in art. Whereas art used Diffie-Hellmans, which are contributive, they require both of the children to contribute something to the key. This is non-contributive. So every node, or every parent node, is derived from just one of its children. When you send out updates, you send out the parent node's secret key to whichever child should know that secret key and simply send it as an encryption operation rather than through any derivation. And then for the most part, the properties are pretty analogous to art. The tree structure is the same, but we have a couple of potential big improvements. One of them, and which I think was the main motivation behind this design, is that multiple updates can now be potentially merged without conflicts, because the non-contributivity means that no one needs to know one of the two children's private keys to update any given parent. And also because, as I will cover in a sec, the keys are derived just by hashing one of the children keys. Once you know one of the private keys, it's pretty much an O1 operation. It is a logarithmic sequence of hashes, but because they're orders of magnitude cheaper than asynchronous operations, we treat them as essentially free. So the way this works, we have a new derived key pair operation, which maps a random bit string to a public key pair. But this is a public key pair to use for encryption rather than key exchange. Could still be Diffie-Hellman, but doesn't have to be. We have abstract away the specific algorithm. And so you'll see here that you've got this, the parent is hash of A. B's key doesn't come into it at all. So this is what the tree looks like. The various definitions are exactly the same, but you'll see that you've just got different values here. So C in this instance was the most recent person to update, so C's key is represented at the top. But at each stage of the tree, you have the node was derived from one of its children. I think I just always went for leftmost apart from C in this example. This is exactly the same. The slide was just copied. So you just to demonstrate that you can use it exactly equivalently. So in this instance, to have a group initiated add, you generate an add key. This is just a random sequence of bits. You encrypt that add key to the new user using their init key. So that's this ciphertext add key in the struct. You calculate the sequence of private keys and public keys up its path, and then you publish all of the public keys in the path keys. Sorry, you publish all of the private keys in the path keys, having encrypted them to their sibling. So in this example, hash of add key is encrypted to C's key, and hash squared of add key is encrypted to the hash of A's public key. And this allows everyone to calculate the root with just one single decryption. So the next operation, the user-initiated add, this is again pretty similar to art. So it's just D is adding themselves. So they take their own randomness, hash it up the tree, encrypt the relevant hashes to the to the public keys of the other children. And D's key is now at the root of the tree. For an update, so if we imagine in this situation that A had been the most recent person to update, at the point that B now sends their update, again, the route to the path is just completely rewritten, completely unrelated to what it was. Then finally, remove, we're looking at exactly the same processes in art. Just send out an update for someone else's key. So the key comparisons here are, so first in the update complexity. So whereas art, every update is essentially a log n operation, pretty much everything in art is log n. TreeChem updates are log n for the updater, but they are just their O1 in terms of expensive operations for everyone else. And in terms of concurrent updates, because of the non-contributivity, it's much easier to imagine multiple updates being handled at the same time and having some decision to which wins without having to discard any in its entirety. Art has a few situations in which it might be able to handle concurrent updates, but it's much more restricted. And one note here from the academics is that we have not fully studied TreeChem's
PCS properties here. We've got slightly better idea of arts properties, but that is incoming for TreeCam, I believe. In terms of open issues with both, this is the same as it was with art. So we've got to prove the various operations security within the model that we want, figure out the logistical details around removing, message sequencing, various other topics which have either been covered earlier or will be covered later today. Also attachments. This slide was copied from last time. This is not so relevant to TreeCam and art specifically. Cool. Any questions / comments?
Yeah, so I think the salient question for the moment, you know, that what we need right now in order to keep the protocol moving forward, just to kind of tee up the discussion for everyone, is we need to decide, you know, which of these or both we want to move forward with. So in the rev of the protocol draft we produced for this meeting, I just put in a switch and said, you can do either of these as the inner loop of your MLS. You know, either you can have an MLS group based on ART, or you can have one based on TreeCam. And I'm guessing that's probably not the optimal outcome. So I realize we might need to do some more verification about the properties of some of these algorithms. But I'd like to know, like, it seems like these are pretty easily swappable, so maybe we can proceed with one while we do that verification. So I'd be interested to hear, you know, whether people think we should pick one or keep both, and if we should pick one, which one we should operate with for the moment. So personally, back on your salient comparison points slide, I am less concerned about the concurrent update benefits now, given the last discussion we had. So if we have a strong assumption about consistency in the received transcript, then in principle, you never run into a situation where you need to merge concurrent updates. And the only way that might be useful is if we really have a bad starvation problem and we need to do some merging. I'm also worried because from a protocol point of view, even if you can cryptographically merge the updates, you need a way to communicate that. And so you need some, you know, language to say, here's the set of updates I have merged, and I'm using that for this epoch. So I think it introduces a lot of complexity. So I think the primary advantage to me here is in the performance difference. And that I think comes with a cost, because TreeCam requires several more primitives to have in your code. You're not just doing DH, you also need a public key encryption primitive. So it seems like there's some drawback there too. So honestly, I'm not really, I don't feel like there's a strong winner here, and so I'm looking forward to hearing from other people.
Yeah. You should also mention, actually, TreeCam update messages are about double the size of Art ones, but not order of magnitude difference.
Hi, relaying from Catriel Cohn-Gordon. She'd like to hear on list from some Federation positive people about the concurrency assumptions. She expects they have situations where it is not satisfied.
Stanislav Mishlev. Thank you. I really think that both constructions worth considering. I'll just want to add one point that TreeCam, if we could be sure that it's really secure regarding PCS properties, has one more advantage. It's much easier to build implementations that is resistant to side channel attacks, because we really have much less public key calculations in some points that can be quite frequent. So I think we really need to try to evaluate and assess TreeCam's properties. I think that maybe CipherG can help with that. That can be pushed to CipherG, and personally I'll be happy to try to help with this. And as it was mentioned, both constructions seem to be more or less equivalent in the set of interfaces, so we can proceed without choosing one or another one right now. But if we could prove all properties of TreeCam, really, personally, I prefer it as construction. Thank you.
Ecker, let's go to Benjamin and then Karthik, then we'll go to you.
Great.
everyone, Benjamin Bordouche. I guess it's better now. Can you hear me this time?
Yes.
Yes.
Okay. So I don't think I agree with Richard on this. I think we should actually keep both constructions in the spec right now, because we still need a lot of analysis, right? Both on art, because it's been studied only for static groups, and for TreeChem. And I don't see an actual drawback in keeping both in the spec at the moment. That's it.
Thanks.
Hi, this is Karthik. Thanks so much for the discussion and the slides, John. I think it made it very clear. I think what's very clear from the slides as well, I think for a lot of you, is that there are lots of commonalities between, on purpose, between the structure of art and TreeChem, which means that many of the issues that we will see about authentication, about message authentication, and so on, are completely orthogonal and will apply to both. And there are many open questions which are on both as well, especially to do with authentication, as we'll see. So on the analysis, indeed, TreeChem is newer and has received less analysis than ART, but we hope to address that in the coming months and have a full proof. That's what I wanted to say. Thank you.
Thanks.
Yeah, Eric Pascola. So I think I differ with Richard, but in a different way. Despite the fact that the system requires transfer consistency, it doesn't require complete lockstep behavior. And so the impact of having the one-at-a-time updates of art is going to be an enormous number for any large group, an enormous number of rejected updates that are predicated on the previous crypto state that then get bounced back if any significant message latency, and any significant rate of key change. Now, if you're changing once a day, this will almost never happen. But if you're changing, if you have a significant size group and people are attempting to change like essentially every message, the way like some systems do, then you're going to constantly have collisions, and it's going to be a lot of back and forth. So, so I do think that's a significant issue. In terms of handling the problem, I agree the problem of figuring out which sets apply to which epoch is a real issue. Though it's not, I guess what's important to recognize is that it's straightforward to label the epochs, essentially by which set of updates have been applied. And so you can always figure out which keys apply to which messages apply to which epoch. What's difficult is effectively knowing when you can, because the epochs effectively, because multiple updates can be applied in the same epoch. What's difficult is knowing when you can discard the keys that were required to basically advance the next epoch. So, I'm at epoch 0, and that includes basically updates A, B, C, and D. Then at some point I say, well, and in order to process A, you get A, and you have to keep that you're like epoch 0 plus A. And and then in order to process B, you have to have the zero epoch, and so at some point you'd have to discard 0, or you didn't get any value. And so the difficult question is knowing that answer. But we talked about that a little bit, and so I think there are some ways to do that. Basically, effectively, you keep it for some period of time afterwards, and then because you have transfer consistency guarantees, everybody agrees when they can discard the keys, and so you will occasionally get people who get bounced, but it won't be very common. This isn't to say that I think that we ought to necessarily have TreeChem. I think what I would say is, going back to what Stanislav said a few minutes ago, it seems to me that in terms of properties, in terms of observable properties, TreeChem has largely superior observable properties to art. However, it's less clear that it's safe. It's less I don't know if it's safe, but it's less clear than with TreeChem than art. So I think but on the other hand, we're also not proposing to ship the protocol today. So I think what we ought to do is operate in the assumption that both of these are secure, which may be false, but operate in the assumption for the moment, and attempt to sort of work out as soon as possible what the operational details of each one of them is. And if we convince ourselves that whichever one thinks operational is superior, we should cross the other one out of the draft and put it in some it's Git, so we can just put it in some stash and get back to it later. And take that one out of the draft temporarily and proceed with the other one. And I'm not saying to do it today, but perhaps at an interim if we were to do that, and but relatively soon, and then proceed with the other one. And if it turns out that there's a serious problem, then we have the other one sitting in the back burner for us to pull back out. But having given that we're not provisioned to ship tomorrow, having two alternative mechanisms to sort of reason about, I think makes life harder.
I'd just add to your point of about TreeCam can definitely merge updates in a way that Art can't. Catriel did have some questions about whether PCS is actually preserved when that happens. So it could be that you're merging updates to no effect, or to no security effect.
Ben Kaduk, as responsible AD, I wanted to point out, please do not send a document to the ISG that has both options in it, unless you have some compelling difference between them that would cause you to want to pick. And if that means keep them both in the document and flip a coin after working the last call, I'm totally fine with that.
Cool, thanks.
Robert again. So I just want to emphasize the update complexity on the last slide here. So particularly for passive participants, which is all of them except the sender, there's a huge performance difference between ART and TreeCam. And we were saying earlier that we might want to have some recommendation on how frequently keys should be updated. So in large groups, and we've been talking about up to 50,000 so far, that will lead to a lot of handshake messages, a lot of updates that all need to be processed by all participants all the time before you can actually even decrypt the next message. So that's a very high load during an idle time, basically, even if nobody is really writing anything. So TreeCam uses hashes, which are incredibly fast compared to public key operations or Diffie-Hellman operations like in ART. So I think this is something we should absolutely keep in mind. And right now, TreeCam on the performance side seems to stand out quite a bit.
Absolutely.
So just to compound the issues Ecker mentioned, this is Richard Barnes. In addition to the when do I throw away state question, if you allow concurrent updates, you also have a question of when I want to update myself, what state do I build on top of? I mean, in the worst case here, you can imagine this branching tree of states that everyone has to maintain. In TreeCam. So it seems like you start at 0, A updates, A, B, and C update. And then someone updates on top of AB. Someone updates on top of BC. And you have at least this kind of woven texture of updates.
I mean, so I don't think, maybe we should take this offline. I mean, there's a temporary period where that kind of happens, because it's absolutely true that, so I guess, when you say updates, any given set, So that may be where Ecker was going. I think is that within any given set, updates are kind of flat and parallel. But when you do something like an add or a remove, that does bump to the next. Yes, and so you do have to have kind of a convergence algorithm by which people decide on which of those states, because you need for them to choose consistently, or else you get ramification. So that's one observation. I had another one, but I've forgotten it. The way forward I was going to propose is that I think we're going to propose at the end of the meeting we get together in September and talk about things. I think one thing it might be useful to do is kind of keep this ambiguous until then, and try and do some initial code, see how big the performance difference is, see how big the message size differences are. And so we can kind of take some quantitative measurements to see how bad the differences look. And I've just remembered the other point I was going to make, which is I think I'm not sure if you mentioned this. Well, you mentioned they have the same underlying tree structure, which seems to indicate that they can be hybridized, which is probably pissing off Catriel and Karthik even more than they already are. But if we see that, say, updates are going to be super frequent, and so we want them to be performant, and we're willing to take message overhead for that, maybe we use TreeCam for update messages, but for adds and deletes, we use ART because we want them to be small. I mean, I don't have a preferred solution here, but I just wanted to point out that those solutions, I believe, are possible if we can, dot the I's and cross the T's, and convince we get assurance from the academics that it's okay to do that.
Sure. So that would require multiple trees, right? Same structure but different trees, because the internal keys are totally different.
The internal keys are derived in different ways, but ultimately they're still just the H keys. Oh, well, so assuming we're using something like ECIES for the public key encryption, assuming we have algorithmic consistency between the two.
Sure.
Comments from the Jabber, facepalm. And that's from Catrill and Benjamin both.
Siobhan Sahib, if you do decide to go forward with both options for now, I think it'd be useful if we at least mention in more detail what the advantages and the disadvantages are, maybe in a separate draft or maybe in the same draft. I think that'd be really useful from an implementation point of view.
Sure.
Madam Mara, I also want to respond to Rafael's comment about the performance of the hashing. Please, Richard and John, correct me if I'm wrong. There is still log-in public key encryption, right? It's not only hashes.
Only for the updater.
Sure.
Yeah. Great. Did we want to do a hum of how we move forward, or?
So what are we setting down the document? Okay.
Cool. Thank you.
All right, so we're going to move forward with message protection. Ben, can you step up to the remote stage? Benjamin Berdouche.
Good. Okay, sorry. Okay, so right now, so I'm going to discuss a bit of message protection, which is currently not in the draft. Next slide, please. Again, please. Thank you. So right now in the protocol document, there are basically nothing about message protection, which is obviously a big part of what we want to achieve here. So there are multiple possibilities about that. We could actually include the message protection part inside the protocol spec, or we could do it outside. My personal opinion is that we could put that in the protocol spec because it sort of makes sense. But we need to define many things. So the main point of message protection, right, is to go from the unchecked key schedule that's been shown by many people before to go to the, let's call it the application key schedule. So basically going from the epoch secret, the group epoch secret, to the encryption of application messages. And to do that, we need this schedule, this application key schedule, and we need a set of algorithms and to define the objects that we really want to encrypt, right? Next slide, please. So that's the current, that's what is currently in the protocol spec, right? The unchecked key schedule. So basically, it does work for both ART and TRICM. It's completely sort of separated because the update secret, as you see on the left, is generated from the root secret of the TRICM or ART trees. Then you derive a group epoch secret, which is basically the most important part of the protocol of the secret, because everything in the group epoch is going to be based on that thing. So depending on the security properties that we want, we'll need to keep that around or not for a certain time, etc. Right now, the message master secret, which I call the application secret, because it's at the moment used to compute keys, etc. is the most important part. What can happen is actually we derive the keys from that secret, from the application secret. So like basically completely splitting the unchecked part from the messaging part. While of course every cryptographic keys that is going to be used to encrypt application messages is obviously dependent of the epoch secret in terms of security. Next slide, please. So from this application secret, there are actually many ways of deriving keys, right? We could do many things. We could directly ratchet this application secret, or we could extract and expand this secret to get ADID keys. You could even directly imagine, instead of having this application secret ratcheted, you could imagine instead directly expanding all the N keys for the N participant at that point. And I'll explain why it's actually a different approach, which has different security properties. So if you consider that you have this application secret, there are multiple ways of going, right? You can directly ratchet this group secret, this application secret, in two ways, either in interleaving the sender contribution or in parallel, meaning that you can either fork this application secret, one for each client, and then ratchet independently these secret chains, or you can ask for each participant each sender to ratchet its next message key from the same group ratchet, and those have very different properties in terms of. The security properties are some sort of the same, but the forward secrecy is not exactly the same, because you need to keep around more things in the case where you ratchet per participant. So let me show you some examples. Next slide, please. So here is, for example, it's a complete example. Nothing is set yet, and we discussed. There are basically as many different key schedule as you want, but there are basically these two categories of per group ratchet or per sender ratchet. So here is an example of a group ratchet. You have like the initial application secret, from which you derive, the sender derives an AAD key and a nonce. And this application secret is going to be ratcheted in a way that each sender is going to contribute to that ratchet. So this is nice because it allows each participant to keep one group ratchet, but it's actually bad because it forces sequentiality of the updates, right? So in some sense, it's not good for parallelism, and it's very wrong for out of order. You can't really do out of order messaging out of this thing. Next slide, please. And then you have the per participant case. So you can, next slide, please. Where you could actually, from the initial group application secret, derive many initial application secrets, one per participant, and ratchet this participant application secret instead. Meaning that this is now completely independent. Each sender has its own ratchet. Basically, it's mostly what is done in current protocols, right? You ratchet independently. Of course, we don't have the experience of multi-party, but large experience of large number of participants in groups. But for that scenario, the drawback, the benefit is that you can actually encrypt in parallel and send messages in parallel out of order. Even if you skip, even if you reorder two messages from the same sender, as long as you keep the key n-1, you can recompute n plus 1, n plus 2. The obvious thing is that this is forward secret, but this is not. This does not have PCS, right? because you ratcheting forward doesn't give you PCS. Only changing, and in that way, if you want PCS for messages, you only can ratchet you need to update the group secret, the epoch secret. So that's very different. So there are three basically very different approaches, where one is you directly deriving n keys or one group, n application secret or one application secret for each update to the group. And you only have one set of keys per participant for each epoch group. Or you can basically have forward secrecy for the keys of the IED keys for messages, but you don't have PCS until you refresh the group secret. That's my understanding. Next slide, please. So the slide I showed before was basically TLS based, meaning that there is can you go back? Sorry. There is from the application secret, you HKDF expand label, an AAD key, and an AAD IV. So that's very useful because it's good for misuse. It's good for fighting against reusing the nonce, because for each message you can imagine you're ratcheting the participant application secret, and you get a new IV and a new key, so you don't risk reusing the nonce. So that's very TLS based because it has like the right key and the right IV that are mixed in back into the application secret ratcheting chain. And there is the next slide. There is a proposal that's been done. That both proposals are actually in pull requests right now on the repo. This is a proposal from Alexei that basically is very similar. It's a per participant ratchet where it's more like a signal in some sense, where you expand both the chain secret, message key, nonce, and you chain the chain secret, but you don't re-include the message key in the chain. And both, I believe, both are reasonable approaches. We still, I mean, we can do many things, as I said. All of those things should first come from defining exactly, precisely the security properties we want for messages, for keys, and for the group epoch secret, because those properties are very different depending on if you want, and the method we have to adopt depending on which properties we want will be very different. Typically, ratcheting the application secrets inside the same epoch, or only generating keys for every participant once per epoch secret. Next, please. So as I said, basically it's a balance, and I don't see any good way of solving that problem now. So it needs a lot of discussion. I don't think it's ready, but I'm pretty sure we can do something that works. And I think everybody is convinced after the discussions we had with each other informally that we can make it using any of those ways, but it's unclear what the exact security properties are at the moment. So we'll need to define them more. So of course, group ratcheting, you reduce complexity. You improve forward secrecy in the sense that you don't keep around application secrets per participant if you don't use them, because you ratchet everything, so you only have one application secrets that's updated frequently. But it doesn't handle out of order, and it's the opposite for the per ratchet part, for the per ratchet thing. Okay, next, please. So in that setting,
One, Ben, there's the question from Ecker.
Okay, yep.
I don't understand this last bullet point.
Which one? Weaken forward secrecy. Okay, so that's a sort of abusive term saying that you are forward secret, but the duration in time where you keep the keys is different. If you keep the keys for like 2 weeks without updating the group secret, or like 2 years or whatever. You still are as long as you are forward secret, it's fine. But the way you have to store the keys, you have to keep them for a long time. It's not the same thing as if you ratchet the key for every second or something. So
the keys aren't protecting anything. There are no messages encrypted to them, so it doesn't matter.
Yeah, but if you encrypt one message and then you prepare the next key for the next message encryption, and you wait for a long time, then you can lose that key, and this key is going to be useful at some point.
I don't understand this. This doesn't seem right.
Well,
I mean,
okay.
first of all, if the group is ratcheting, then every time if the group ratchets, then you have forward secrecy because the old key is just blown away, and forward secrecy about keys has already been, the future of keys have already been used. So if the key's just sitting there on the disk and it's never been used, then I don't understand what the problem is.
For the group, it's fine, but the point here is not necessarily to the point of the weakened forward secrecy is as I said, so an abusive term to say that we should also consider in the security measurements we do, like in the security proofs, keeping your own keys is always bad, right? So my point was just to say we should be careful how long we keep the keys when we do that. That's all.
I mean, I have some keys which don't use to encrypt anything, so I think keeping them around is probably okay.
That's fine.
I guess maybe there's some formal property here you're referring to, but I'm not following what actual security property you're trying to talk about is.
Sure.
So maybe it'd be useful to. I mean, I guess it's probably not particularly useful to make this particular point.
Okay, maybe not.
Because I don't think it's a high point in determining which of these is a more attractive system. But I also don't.
Anyway, I do agree that the per participant one is the obvious, is the preferable choice. I mean, in my opinion, but.
Well, I didn't say that. I might be glad to say that. I didn't say that. Yeah.
Okay, can I go on? I have one more slide, and then. Okay, can you go to slide 11, please? Next one. Again, the next one again, please. Yeah, this one. Okay, so there are, as I said, there are two parts we need to handle: the application key schedule and the message protection itself, the encryption. I think for the message encryption, we can use very straightforward things like AAD encrypt everything. As discussed before in Emad's talk, I think there is the padding issue. So I wrote some initial text in a pull request, and I'm in favor of, as I said before, I'm in favor of padding. I'm in favor of MLS providing a mechanism and leave it to the application to decide how to use it. But my point is that we should not leak the length of the application messages to everyone for each encryption. And then there are, depending on how you authenticate, currently the authentication is done by using signatures. Depending on how you authenticate, there are things that you should put inside the ciphertext or not. Typically right now, having the signature for authenticating the participant strongly, meaning knowing which authenticating the specific sender to other members of the group is done using signatures. In the current setting, we can actually encrypt that signatures and put it inside the ciphertext, and it would be safe because we have an implicit authentication property on the fact that if you can decrypt the ciphertext, it means you have the IEAD keys to decrypt the ciphertext, meaning you are a member of the group. And that's all. Next slide. I think so. In a way to move forward is, I think, since now we have nothing in the text, a safe approach would be to define an initial message protection text, where we use something very straightforward that I think people can reasonably agree on. Typically, having like a per participant ratcheting scheme using AAD ciphers, optional padding, and optional signature of the plain text, the ciphertext. And there are basically two pull requests on the specs that provides that. And I think I'm done.
So yeah, I agree. We should go ahead and get some stuff in the document here, put a stake in the ground, and start actually writing some protocol. In terms of the key schedule, could we skip back to that slide? Because I figure it's probably going to be, forward the comparison one, that one. For me, the kind of killer app for the group ratcheting is the reduced storage. If I'm in a 10,000 person group, in order to get any forward secrecy, I have to generate and store 10,000 keys.
30 kilobytes, oh my God.
I mean, constrained devices, hand wave. I mean, but also these devices, I've got an account, an app that has, it's in 2,000 groups maybe. So I think that complexity advantage seems to me worthwhile to do the group ratcheting thing, at least to try it. I don't think the out of order thing is going to be a big deal, but I think that's something where some experience will be helpful in determining whether it is actually empirically a big deal. I think much like the ART versus TreeChem here, I think what we should probably do tactically is pick one of these, go with it, but keep the other one in the back pocket if we need to switch it out. I think this is a component that can be fairly modularly swapped out in the future. Yeah. One other thing I would push back on the last slide is this idea of optional signatures. I think my assertion here is that we always want to know who a message is coming from. I don't have any use cases for generally getting a message that came from someone in this group, and I don't care who it was. So I would propose that we make the signature field mandatory, a built-in, always there part of the message protection format.
So my take on that would be that maybe we can do it for unchecked messages and leave it to the application to decide for the application messages.
I mean, to a degree, any work on a message protection format here is kind of optional for applications.
Sure. Okay, I see what you mean.
Much like people do at TLS, like the DTLS SRTP uses the TLS handshake with SRTP encapsulation. So, I mean, in principle, you could do the same thing here. But I think for the default case we have here, we should go ahead and have that level of direct authentication.
This is DKG. I'm just going to plus one what Ecker said earlier about not seeing the forward secrecy advantages that were claimed for group ratcheting, and that participant sender seems like the clear win to me.
Yeah, I sense that Richard and I have a philosophical disagreement about the level of lockstepness of this protocol. My concern actually is less about the necessarily out of ordering, but about the receiver's implementation of how much window he needs to keep of old keys. And we've spent an inordinate amount of time in Quick and in TLS trying to reason about what happens when things get reordered and what happens and exactly when you can cut over from state A to state B and then get these messages from random people in the mailing list or not random people saying I have found this case where if you do the following 19 things, things go to shit. And so that, and what those things turn into is incredibly ornate receiver side algorithms for figuring out where you can time out keying material. And given that, as far as I can tell, effectively the only cost here that that IE is actually bearing is 16 to 32 octets of state for basically per peer, and that every messaging app with which I'm familiar, A, keeps a transcript of the messages, and B, keeps a list of everybody in every group, and all those things are much larger than the keying material. I just that seems making a lot of program complexity for the false economy of saving a really small amounts of data just does not seem like a reasonable structure.
Yeah, Robert again. Can we go back to the comparison slide, please? Yep. So initially I had the same reaction than Richard when I thought of all the state, but then I'm more with Aker. When you really think about that, what that means, it's we talk about kilobytes, and it's also not clear if we have to keep all of it. Potentially this is only between two group stages where we have to keep stuff. We don't have to keep things for passive participants. So in very large groups, it's potentially still not a lot of state we have to keep. So in my opinion, I strongly favor the second one for the participant ratcheting, because the other one means that we might again run into the starvation problem if we conflate that with handshake messages. So we typically would expect text message to be relatively high frequency compared to handshake messages, which means that there is a real risk of starvation there, which we don't really have if we have a per participant ratchet.
This is DKG proxying for Karthik. Karthik asks, it is unclear what the security guarantees of application key ratcheting are. It only provides forward secrecy against a very weak attacker, and only if all receivers, including passive receivers, regularly delete old application keys. So the question is, do we even need application key ratcheting as long as the group epoch secret is frequently enough updated?
Exactly. So that's the thing I mentioned at the very beginning about PCS, about directly extracting one set of N keys for a sender per epoch secret directly at the beginning. And depending on the exact properties we want, that might actually one of the only way to get the PCS for the check message, for the application messages too. And maybe, maybe while you're Richard here, you can talk about, I didn't mention the new tree-based application key schedule thing that we were thinking about. Maybe you can give a word on that too, because
I think I've forgotten what it was we talked about.
So basically, we discussed the fact that we might be able to improve on the storage for the per participant ratcheting thing by having tree structures to store the.
Yeah, I remember this now. So you could build a structure where you had started with an application secret, and hashed it in two directions to cover halves of the group, and then so on out. So you have up to the leaves. To seed out those roots, and that way you could only store intermediate nodes in the tree and opportunistically generate things as people transmit. It's a mild optimization over the per sender ratcheting. I wanted to come up and respond to Ecker's notes about reordering. I expect on this topic we actually don't disagree about lockstepiness. I don't think there's any need to assume lockstep for messages. I think there's a sort of reorder, and here we want to have a reordering window in the receiver. And I think that actually argues for the group ratcheting though, because if I've got a fixed size buffer for maintaining keys for reordering, in the per sender ratcheting, I've got to maintain number of participants times reorder steps keys in order to have reorder steps keys for each participant. Versus in the application, in the group ratcheting context, I only have to maintain reorder steps keys. No, you disagree?
The issue is that inter-participant reordering is much more extreme than intra-participant reordering. So if I mean that one way in which a participant gets reordered, right? One way in which reordering happens is I send a message with my then current key, but I'm not online, and so now I come back online in 10 minutes, and now that message is like way the hell reorders, but everything else, and so but that's like different. But if I reorder, like if messages get reordered between the things I transmitted, it's generally common that what's happened is you had a message loss, it'll be retransmitted like almost immediately. But so that reordering window can be relatively narrow. But if you want to be able, like, if you have, I mean, let's do the math. If you have a group that has, 10 messages a minute, which isn't uncommon, and you're offline for 10 minutes, you're now looking at like 100 message reordering window. Like 10 minutes, like easy, right? 10 minutes, like, is the difference between your car goes into a tunnel, or you go in an elevator. And so, reordering windows just aren't comparable.
But even in your example, I have to maintain, 100 key backlog of application secrets in order to be able to do that reordering, and which is a lot less than the 10,000 that was the size of the group.
Well, depending on like how much we're going to really tolerate. I mean, like I've seen Slack messages reordered for hours to days. Someone was on an airplane, right? But more generally, you also don't need to retain you also don't. The only reason that you think you need to retain like a long wind like that is so like the way you structure this is a strike register, right? So basically, so like you don't need to like because the keys are generated in a forward chain, right? What you do, basically the data structure you need to maintain is effectively the next hop is basically like
it's not a strike register.
Okay, depends on how you build it. There's a number of ways to build it.
Well, I think in Benjamin's proposal, it's not a strike register because the application keys aren't single use. So you could do it by maintaining a single end key, like the first thing from which you can derive forward.
In any case, like I'm not sure how to resolve this, but you seem to be under some impression that like the amount of storage available to the client is like incredibly small, whereas these clients are have like an enormous amount of storage, and they're very powerful, and and by and large, like I say, they store the transcript of all the messages, which is like enormously larger than like any possible set of key material. So like unless you can demonstrate that I guess I want to see an argument that like you have to store like amounts of data that are comparable to the size of the photos of your iPhone before I'd actually be concerned with this being an issue.
Matthew Miller, I think at the end here, I'm basically just agreeing with Ecker here, and I think it is important to remember, like when we're talking about high transmission, high frequency of transmission, sometimes groups get super duper active, and trying to deal with that kind of problem. I mean, I've seen this in the past with other clients where per message ratcheted keys are in use, and there's been essentially the group becomes unusable for a period of time until everybody finally syncs back up. So, I mean, if anything, I'd either be arguing for the per participant sender or just not worry about it for right now.
Let's close the line after John, so that we have time for the next presentation.
This is Madam Mara. I agree with Ecker. Storage, local storage is the least concern in this protocol. Like, whatever way how to design this. So I disagree with the red point that higher complexity storage is an issue for per-sender ratcheting. I also think the other one, as Ecker said, is wrong. So I guess there is no red actually things with per-sender ratcheting. I think for me it's intuitive. It makes more sense.
John Milliken. So I just wanted to respond to Ecker's point, which I do broadly agree with, actually, that I don't think we need to worry too much about storage space, but I'd like to be careful that we don't build for modern iPhones and we build for low-end circa 2012 devices or something, because we still support them in many of our products.
Also iOS.
Jonathan Lennox, we were briefly chatting on the Jabber, came to the conclusion that if you want per participant signatures, which Barnes said he wants, that means you need each participant's public key, which is going to be a lot bigger than this key anyway, also.
So Benjamin, it sounds like you and I should chat and game out some models and provide some quantitative estimates of what we need.
I think that's the next good step.
Thanks, Benj.
Thank you.
So yeah, authentication and I get the clicker. Point it at the Chromebook. Voila. All right, so those of you who've read the protocol draft recently have seen there's a fairly basic, fairly naive authentication framework in there. It assumes that each participant has a long-term identity key and that user init keys and group init keys are signed with those identity keys. And in the group init key case, we also include a proof of that proof that that identity key is a member of the group by committing to a Merkle tree over the identities in the group and providing a proof of inclusion in the group. Am I getting feedback here? Oh, okay. I thought I was hearing a little bit. Likewise, when we send handshake messages, we include a signature by the identity key and a proof of inclusion. One thing we'll need to keep an eye on as we go forward is that the authentication we want to get in the long run is going to be about identities, email addresses or usernames or something like that, not public keys. And so we'll need to add credentials at some point, which we don't have in the current draft. So I want to step back briefly and think about requirements for authentication. What do we want to verify at one point? Now this is again to the academics. This is not the precise definitions. This is kind of taking a functional view of what does a participant in a group want to verify at different points in the life cycle of its interaction with the group. So when a client connects to the group, it's going to want to verify who the other members are in the group, so it knows who it's encrypting to when it encrypts to the group. So this is something in which I think Karthik and Benjamin might disagree on, because there's some ideas that you might just want to know that when you receive something, it's from the group, and so you might not care about who the other members are in the group. Likewise, when you receive a message, you want to verify something about who it's coming from. I'm going to assert that we should verify the precise identity of the sender, either at a user level or at a device level. You could also argue, as I think Karthik and Benjamin have, that you might only want to verify that at the group membership level. We can have some discussion about that. If I'm in a group already and someone joins, we'll need to have a way to verify the identity of that new member to kind of update the roster we have, the roster the client has, the idea the client has of who's in the group. And when we remove, the interesting case here, the one that's different from the others, is that removal requires knowing a copath for another node. So this is different because it's not about identity verification. It's about verifying that you have the same crypto state as the rest of the group. So just to graph that out, if we imagine the case where node F in this tree wants to evict node J, as John was detailing earlier, F needs to generate an update for J, which means it needs to generate those solid orange nodes on the path from J to the root. And in order to generate those nodes with a new leaf value for J that J doesn't know, it needs to have those orange outlined boxes. One is labeled I, and there's an arrow pointing to the other. But F, under otherwise operation of the protocol ignoring removal, is only going to have its own direct path and public keys for the copath. And so it needs to have a way to download, so there needs to be some information distribution to distribute the nodes, but more importantly, F needs to be able to verify that when it gets these copath nodes from some source, that they're the right copath nodes. And if you want F to be able to evict anyone else in the tree, then it needs to have the whole state of the tree. It needs to have the copath for every node, which means it needs to have the public keys for every node in the tree. And so we need some channel for effectively authenticated distribution of the tree. So we have kind of two classes of authentication problem, authenticating identities, authenticating the tree. We also have kind of two, I'll say functional, two kind of points in the life cycle of the group where you need to verify things. You have points where you are already a member of the group and you're trying to authenticate something about the group, some incremental change about the group, and you have the initialization step where you're joining the group and you need to initialize your state with the authenticated roster. So I'll kind of treat that on-connect initialization question as separate from the once you're connected to the group cases. So I think these post-connect cases are a little bit easier. In particular, message authentication is really just a signature. Benjamin might want to make it optional, but I think we should require this. In the current draft, we include a signature together with a membership proof. The proof that the identity key that signed the message is recognized or part of the Merkle tree of identity keys that was committed in the group init key that kind of defines the group. That's handy if you only want to cache on the endpoints that commitment, the head of the Merkle tree, and not worry about storing the entire list of identity keys. but maybe we're not worried about storing a ton of stuff and we're willing to cache all the identity keys. In that case, you don't need the membership proofs and we can leave them out of the protocol. And as Benjamin just presented, there was, he's got some stuff in his PR about how exactly you encode the signature. It's not, there's no magic. It's just a signature over the message to authenticate that it came from this public key. For authenticating new joiners, I think it's similarly pretty simple. It's going to be about signing the user init key that's presented as part of a group initiated ad, or the user ad message that's presented as part of a user initiated ad. Signing the content of those messages with the identity key and presenting a credential at that stage. And I think the concretely, and I apologize for presenting this as slideware and not a draft, but I think the right answer here, which we'll probably get in the draft soon, is something that kind of looks Sigma-like. So if you're familiar with TLS, the way authentication is done in TLS is the authenticating party sends a certificate message. It sends a certificate verify message with a signature over the handshake transcript and the certificate. And then it sends a finish message, which has a MAC over the handshake transcript, the certificate message, and the certificate verify message. So you have effectively a consent of the private key holder to join the group, and then with the MAC under the new group key, kind of consent of the group member to have that identity. So I think we can kind of map that into this group space by maintaining some transcript hash, which I'll talk about on a subsequent slide. Maintaining some transcript hash, assuming this lockstep handshake process, assuming consistency, and then incorporating that into the message authentication with the signature and the corresponding MAC. So that's kind of the cases where the authenticating party is already a member of the group, or where the relying party verifying the authentication is already a member of the group. Initialization is a little more challenging because it's linear size, and linear is not a word we really like around this group. We really prefer log or constant things. But when you're talking about the list of members in a group, that's kind of irreducibly linear size. You have to talk about n things. And when we're talking about also authenticating the tree, you have 2n intermediate tree nodes, roughly, give or take, plus or minus 1 or 2 nodes. So it's roughly twice the number of participants in the group. So we have kind of n identities and identity keys to talk about the members of the group, and then roughly 2n tree nodes. And of course, we need the authentication information to prove this is all correct. One observation I think is useful here is that handshake messages that are exchanged in the course of the protocol carry a lot of the information we're interested in here. So whenever a node sends out, say, an update or a user ad, they are sending out the public keys along their direct path to the root. And so if you watch the activity of a group over time, you can build up the state of the tree. In particular, if you observe the last message sent by each participant in the group, you can kind of stack those on top of one another, and then you have the state of the tree at the end, which is kind of nice. And if you have the authentication, then the information you need to authenticate that those are from real members of the group, you have an authenticated copy of the tree, and you know the identities of the participants. So this kind of suggests that we could use messages themselves, the handshake messages that have been sent within the group, as a way to distribute the tree and to distribute the roster. So like I said, if you see the tree, or if you download it from somewhere, or if you see these handshake messages, or if you download it from somewhere, you can reconstruct the public state of the tree as it is agreed by the participants. Now it's, I said we hated linear stuff. It's even worse than linear. Now we have n log n things to download. But again, I think that's, it's not unavoidable, but it's better than some alternatives you can imagine. One challenge here is that if you're going to take this approach of using the messages, you need to verify that, so you want to make sure you've got the latest message from each participant, and that the server hasn't kind of injected a message in sequence or omitted one, injection being the bigger risk. So you need to have some idea of the whole sequence over the set of messages you need. So in this case, C updates, and then AAA, BA, and then B and A update at the very end. And so you need, in order to get the tree, you need those messages from A, B, and C. But in order to trust that those are the correct messages for you to build your tree off of, you need some information about all of those messages in the middle. And so now we've gone from linear to n log n. Now we're at, lower bounded by n log n. We may need more. I think we can do a little bit better than n log n, though. We've already said that we need some degree of transcripts recording. We'll need transcript hashes to do this sigma-like stuff. And so we're already it's kind of hints at building a hash chain out of handshake messages. So at the bottom here, I've got kind of a cartoon. You initialize off some hash, and then whenever you send a handshake, you hash it together with the previous handshake hash and hash chain along in that way. So you can imagine, distributing the handshake messages that you need in toto to build the tree, along with basically a sequence of hashes that demonstrate that there is a sequence of handshake messages in the middle that connects these. So you at least know that you've got a subset of a subsequence of the actual sequence of handshake messages. Likewise, one thing Raphael and I discussed at the hackathon last time when we first realized we had this tree authentication problem is that you could encode in the group init key a commitment to the current state of the tree. And we like to use Merkle trees for commitments because they compress you down to one hash value. And so the figure on the right here is a tree on a tree. Nice thing about the tree structure we're using is that it can very easily be mapped to a flat list of nodes. And so you could take the actual ratchet tree at the bottom, map those nodes up into a list, and then build a Merkle tree on top of that that would give you a commitment to the tree. And so now you've got assurance that the handshake messages you're getting are correctly from the sequence of handshake messages, the handshake history of the group. And using this commitment to the tree, you can verify that the tree you've built out of those messages has the correct collection of nodes for the whole tree. So this is very much kind of how should we do things forward. This should really have been in a draft if I were doing this thing properly, but this is basically my rough proposal for what I think we should be doing to build out an authentication infrastructure in the next version of the draft. It obviously needs a lot more detail in order to be implementable and to be really protocol, but I thought I'd present it here to see if it was looking plausible to folks. So the rough outline is that for these post-connection cases where I'm verifying individual messages or verifying joins to the group, we'll have just signatures as you would expect, and for joiners where we're authenticating identities, we'll have some sigma-like thing where we bring in transcript, the hash of the prior transcript, and we do the signature and MAC dance to cover credentials and to have the counter MAC, I guess, from the group membership. And then for initialization of new joiners, we'll take the approach of using the messages themselves as the distribution channel, or as the things we expect to be passed around by the delivery service. Somehow that the delivery service will arrange for this stuff to get passed around so that endpoints, members of the group can verify that they've got the right sequence, they can build up the tree, they can verify the identities that have sent these messages. So at this point, I'll just open up for discussion. Does this look good? What looks good? What looks bad? What looks challenging? What did I screw up? Etc.
Let's start with Karthik from online. And he disappeared. Okay, get back in the queue, Karthik, and we'll add you. John.
Okay, John Milliken. So a couple of points. One is that in the situations where clients do have a full list of the people involved in the conversation, so for the remove case, why not just store the entire tree on the client? Because it's only double the size, right? There's no order of magnitude difference.
Yeah, I mean, I think that it's totally plausible that you could have clients store an entire tree locally. I think you still need to initialize. I think the hard part is initializing new clients with the tree when they start up, when they join the group.
Sure. But a couple of concerns with your proposal. One is that it seems to require the delivery service to store a lot more metadata longer term about the conversation, and I think potentially a lot of us would like to avoid that if possible.
Yeah.
So I was wondering, why not have just have the server store the entire tree and a commitment from one of the members to the tree in a Merkle tree?
Yeah, so Raphael and I were talking about this yesterday, and one of the things he observed was if you have this commitment to the tree over the tree, then the server could cache the tree and deliver that to people safely. And the server could strip out the identity information of messages. It only needs to keep the tree bits of the messages.
Sure.
And not the identity bits. So you could reduce the amount of metadata that way. You'd still ultimately need to get the identity information somewhere.
Sure.
So that you know who you're talking to.
Right.
But you could get that in a peer-to-peer fashion.
But this then may reduce the requirements to ON storage of the tree states, various tree states now.
That's true. Yeah.
Yeah. Thank you.
Okay, we'll do Karthik now.
Hi guys. So I have 2 points here. One of the comment and the other is a question. The first is that we seem to be requiring this handshake transcript for the Sigma-like protocol, and I would like to observe that the group secret or the epoch secret is already mixing in pretty much the entire history of the handshake. So we might be able to derive something from the epoch secret, and we may not have to keep the full transcript. But that's technical. Slightly more concerning one is that although we are thinking that we may only want to provide a credential Sigma thing for user init and user add, I suspect we may actually end up doing this for every single update, because we are concerned about PCS, and if the signature keys are compromised, then we can't just say that we're going to keep the old signature key for authenticating all future messages. We'll want to roll those over too, which means we need fresh credentials, fresh signature keys, and somehow link the old signature to the new signature key and so on. So I think it's a bit more heavy if you want to compromise security for both signature and development key than what you just showed right now.
Yeah. Can you please explain what you said?
that was a little bit, Karthik, sorry, that was a little bit garbled here. The thing I was nodding about at the end was that I thought I heard Karthik saying that it's difficult to get post-compromise security with regard to signature keys, as well as the contributory leaf secrets we're talking about here, the confidentiality keys. So that is a property of the proposal I'm making here, is the identity keys are long-lived, and so this scheme overall doesn't provide PCS with regard to the signature keys. I think Benjamin has thought some about how you might do that by, say, initializing with a proof with a long-term key, and then doing future signatures with a different key, authorizing a different key that could do future signatures. That personally, I'm less worried about these authentication keys than the confidentiality keys, although I'm not sure why I say that. Would be interested in people's thoughts about whether it's worthwhile to aspire to some sort of PCS with regard to signature keys. Lucia?
Hi, Lucia Ballard from Apple again. So I haven't seen this before, so I might be misunderstanding, but what are the authentication properties for receivers of messages? Like if there's someone who hasn't sent a message for a long time in the group, how long does it take for me to verify that they are in fact who I think they are when I'm sending a message to them?
So just to make sure I understand the question, are you saying there is a sender who hasn't sent for a long time, and now they send, and the question is, how long does it take for the receiver? What was the effort for the receiver to verify their identity?
So it's the other way around. So it's if I'm a sender and I'm sending to a large group and there's some like silent members of that group, but I want to make sure that their identity is in fact the identity I think it is. How long does that take to happen?
So you may have had, so the situation where this would arise is like you've had a sender who's offline for a long time. He may have missed some folks joining the group and he needs to update his state. It's an interesting question. I had mostly been thinking about this as in the context where you are seeing joins as they happen. I think the way I would be tempted to think about that, the simplistic way, it would be in kind of a fast forward context where the simple way you might think about building is to have the server cache the handshake transcripts. And then when someone comes online after a long time, they just download the fast forward version of the handshake transcript, which means you got to read forward. But you're going to have to do that anyway so that you have the confidentiality keys you need to transmit.
Cool.
So yeah, I think it's a little expensive, but at least the messaging overhead you can offload to a server and a server cache.
We'll have Ben ask the next question, and then because there's a few things after this, we'll cap the line.
Benjamin Bardouche here. Okay, so regarding your last point, deniability. The original thought I had, and that's why I said optional signature when I discussed it, is because I personally don't like the idea of signing everything with the long-term identity key. But that doesn't mean we can't get better privacy out of it. As you mentioned, we could. My thinking is that we could actually use ephemeral signature keys for at least to get FS for signature keys. I'm not sure about PCS, but at least you get FS. And the deniability point is if you could. I'm not sure. We might be able to get deniability if we rupture the link between the initial ephemeral signature key from the long-term identity key. By, let's say, the user is establishing a one-to-one deniable channel to send his own private initial ephemeral signature key. So there are things that we could do here to get better things, but we need to think a bit more about it. But in general, I mean, intuition is that we should not sign everything with the long-term identity key.
So what I wondered, just kind of in terms of order of operations, it seems like these schemes for forward secrecy and signature keys, which maybe adds up to deniability, are sort of additive.
Yeah.
In the sense that you could take a scheme that doesn't have that property and add on to it a mechanism for authorizing short-term sign-in keys. So I wonder if we should go ahead under the assumption for now that we have long-term identity keys, and then we can consider later how that might be extended to have short-term kind of signature key rotation, if you will.
Okay.
That would be my operating concept. Unless you think that would make it too difficult to add this at a later point.
It's unclear to me. It might be fine.
Stanislas Mishlev. Yeah, I think that if we have that basic assumption of identity keys that being more trusted, then this is a good start to go, and that will refine all issues if that start with Sigma-like protocol have some issues. I have maybe some basic question, which is continuation of one of previous questions. Do we want to give some exact recommendations about the users that really want to be anonymous, but that want some mechanisms that may be out-of-band mechanisms, so that their direct receivers of their messages or senders to them can verify their identity, but should we provide some out-of-band mechanisms for that, or should we just give some recommendations how to do that? So if I am the new user. I don't know anyone in the group, and no one knows me. But I know someone in personal, and I want someone to trust me. What is the mechanisms for me to be able to prove that I am who I am? There are a lot of techniques in existing messengers, for example, in Vicar, such that video call with just pronouncing your public key. There can be some techniques based on PEG, for example, if you just transmit a short password and then use this to authenticate the short-term session to authenticate your public key. So there's a lot of variety of options. Could you clarify what's your current positions on this, and do we want to clarify this? Because we really want this to be to protect anonymity of the users who want this.
Yeah, so I think as I think Imad mentioned, I think to a large degree, the authentication service itself is fairly separate from this. We need to have an integration point, which I've called credential here. But I think we can keep that integration point fairly abstract. So you can think of it as a normal X509 certificate if you want, but you could also insert something if you want to do a PAKE thing. You could put something in there that would say commit to a PAKE output as the identity value there. The important thing is you need to identify to bind the identity, which is the thing you're going to use in the authentication system, to the public key that you're going to use in this system.
Yes, and I take your point that really it's maybe unrelated to your current presentation. We have a point of integration and that's all. Yep. But regarding the group at all, maybe your slides are more related to the thing that any other. So should we think of putting some large text to security considerations about recommendations for techniques for initial authentication, because I think that it is one of the crucial point for practical security. For example, if you know a lot of strange stories with Telegram in Russia and with such a fight between anonymity of the users and the mechanisms to protect this, I think that it will be really good to add some recommendations about how to protect privacy, but to be able to trust the users who want. Maybe the new group that is being developed in IETF, the PeerG, will be a good place to discuss this issue.
Yeah, I think that's a totally good suggestion to put kind of an outline in the security considerations and then work with these privacy folks to elaborate some other options.
Okay.
Let's be very brief because we have to do a home and we have 3 minutes left. Okay.
Rafael Robert again, I'll try to be brief. 2 things. So one is post-compromise security, and there it was mentioned that there is a bit of a gap between the signature key and the group secret. And so in a trivial setting, you can compromise both if an attacker has access to the local storage of a device, but there might be other ways of compromising the group secret where PCS is relevant. For example, when there is some flaw on the crypto level in the handshake messages, basically you can get access to the group secret, but in that case, you still don't have access to the signature key. So in that sense, your gut feeling is sort of justified there. That the signature keys are actually better protected because they're not being negotiated over any protocol. The other thing is the last point on your last slide, and that is deniability. So I've had a number of offline discussions with a number of people, and really the only common denominator there is that everybody feels about it very strongly. Some of them are in favor of it, others are absolutely opposed to it, and there don't seem to be any meaningful common ground there for some consensus of what could be done. So I think personally the only way of going forward is to have optional deniability. And the practical proposal here has been that we use this Sigma-like mechanism to distribute an ephemeral signing key in a one-to-one way. So this would practically work. Unfortunately, it's quite expensive. So it would be fantastic, of course, if someone has an idea on how to make that more efficient. But it would be a start.
Okay, DKJ, any quick comment? We've got like...
Yeah,
no
so I just wanted to, can you go back to the signature thing? Just wanted to point out there's a potential user experience confusion here that we should give guidance on in the draft, which is that you could, in this scenario, you could have a validation success for blue, say, and a validation failure for red. And if we think that any validation failure should cause the same failure, that's fine. But if we think that there's something else that happens in some other way, we should just be very clear that we expect both of them or none of them.
Yeah, no, I think they both need to pass in order for the message to work.
Right. So then, but then if the inner one fails, what we're now saying is that the MAC, like you're now treating it as though there's a MAC failure. I just think we need to think about what the consequences are there, and we should put guidance in the draft about what to do in that case.
Absolutely.
Yeah. Thanks.
So I think the key point here is that we know that there's a lot of open issues in the protocol draft. And I think that that's perfectly fine because otherwise we'd be done in one meeting, right? That's not really the goal. But I would like to get the working group process started and actually get that document adopted into the working group. Can I see a show of hands of who's read the protocol document? Good, a large number. We are now going to hum for working group adoption. It is not set in stone. It is not done. It's going to get revised. So this is not like what's in there now is going to stay because we know there's stuff that's missing in all 9 yards. So please hum now if you would like to adopt this as a working group item. For Martin, if you would not like to adopt this as a working group item, please hum now. Okay, so it's pretty clear. We'll definitely take it to the list. DKG, was there stuff in the Jabber?
Only a hum in favor of adoption on the Jabber channel.
Excellent, thanks. So notes up here. Some other things that we obviously have to talk about. We are planning an interim since we kind of ran out of time here. And we think we could deal with some real head-to-head time for like a day or two. We're not quite sure when that's going to happen. But right now, the nexus of people that really are working on this are in San Francisco, Berlin, or London. So think about that. And DC. So we'll get back to you. You'll start seeing some messages on the list about confirming adoption of the 2 working group drafts. Thank you very much for your time.
Yeah.